Do you know that as it's growing so fast, our planet might not be able to handle it? Every time we train a large language model like ChatGPT, it consumes gigawatts of electricity. Data centers get hotter than you think, and they need millions of liters of water just to stay cool. If it keeps growing like this, we could face power shortages and massive environmental costs. So, how do we keep AI growing without breaking our planet? The answer might be above your head, literally. An orbit. An orbit, solar panels can generate up to 5 times more energy than on Earth, and cooling, it's practically free. Space is minus 270 degrees Celsius, nature's ultimate air conditioner. No rivers, no water, just infinite sunlight and cold space. Now imagine thousands of computers running ChatGPT in a space that never gets hot, powered by clean energy from the sun. That's the idea behind the world's first orbital AI data center. Here's how it works. Rockets launch modular AI data centers into orbit. Once in space, solar panels unfold, radiators extend, and the modules start working like floating supercomputers. Data from Earth is sent up, a train's in orbit, and results stream back in milliseconds. Now, imagine 10,000 of these orbital data centers working together. That's enough to run a models 100 times bigger than the largest one yet. This is not just theory. Companies like Lumen Orbit are already designing these orbital clusters. With reusable rockets, just 100 launches could create a 5 gigawatt space supercomputer, bigger than the largest data center on Earth. That raises an obvious question. What do you need a computer the size of a small country for? Well, almost everything we do online will be powered by AI soon. Search engines, social media, streaming services, even virtual worlds will run on AI algorithms. We're also tapping AI to solve big problems like curing diseases, fighting climate change, and powering electric cars. As AI takes on more tasks, it needs more computing power. If you've ever tried to use an AI chatbot during a viral internet challenge, you've probably noticed it gets slower when everyone's using it. That's because AI processing takes time. Even a simple request like writing a poem about quantum physics requires thousands of calculations. The more people use AI, the more energy we need to keep it running. And here's the problem. Our demand for AI is growing exponentially. It doubles every 6 months. To keep up, we need a new kind of computer, something much, much bigger than the processors in our phones or laptops. Enter the quantum computer. These machines harness the weird rules of quantum physics to perform calculations much faster. But there's a catch. Quantum computers are really hard to build. They require ultra-cold temperatures and tons of energy. So how do we solve this problem? Send it to space. Now imagine this. You're launching a rocket to deliver a modular data center into orbit. Once in space, solar panels unfold, radiators extend, and the modules start working like floating supercomputers. Data from Earth is sent up, a train's in orbit, and results stream back in milliseconds. It turns out that sending your computer to space is not as crazy as it sounds. For one, there's plenty of room up there. The Earth's orbit is about 40,000 kilometers wide. That's enough space to put more than 2,000 of the world's largest planes end to end. Plus, there's no atmosphere to slow us down. A rocket launched from Earth's surface can reach orbit in just minutes. Once there, it's like being in the middle of nowhere. There's no wind, no rain, no crowds, just infinite sunlight and cold space. In fact, space is so cold that NASA's satellites have to carry blankets to keep their electronics cool. That means we won't need expensive air conditioning or giant fans to keep our computers from overheating. Plus, there's no noise pollution either. We won't have to worry about building soundproof walls around our data centers or sending out noise control teams. Of course, there are challenges to overcome. For example, we need to figure out how to launch all those computers into space without polluting the planet. That's why some companies are investing in reusable rockets. They're also working on ways to make AI more efficient so it doesn't consume so much energy. But perhaps the biggest challenge is getting people to accept this new technology. Some experts say that letting AI loose in space would be too risky. What if something goes wrong and one of the data centers malfunctions? Others argue that we should go for it. The potential benefits are just too great to pass up. So what do you think? Should we send our computers to space? Let us know in the comments below. This is a new series where we explore the most pressing questions at the frontier of technology. We will all look at both sides of the argument and let you decide what the future should look like. Thank you for watching.